Good afternoon, ladies and gentlemen, and a very warm welcome to this discussion forum on rainfall recycling as a landscape function connecting the Sustainable Development Goals 6, 13 and 15. A warm welcome on behalf of both organizations hosting this discussion forum, the Forestries and Agroforestry Program, FTA, of the CGIAR, and the International Union of Forest Research Organizations, IUFRO. My name is Alexander Buck, and I'm the Executive Director of IUFRO, and it's my great privilege and pleasure to just say a few words here at the very beginning of this discussion forum. In this about 1.5 hours, we are going to discuss something that might have the potential to change the narrative, the discourse about forests and trees in landscapes in relation to climate change, land management and other issues. I think you will agree with me that the current discourse about forests and climate change tends to focus very heavily on the role of forest trees and land in sequestering and storing carbon. In fact, there are new scientific insights which indicate that forest trees vegetation plays a key role also in determining rainfall in rather distant locations. In many parts of the world, local people, if you ask them, they are convinced that forest and trees not only depend on rainfall, but they also play a critical role in actually generating it. And that is basically what this session is about, and the science increasingly generates insights which confirm this perception of the local people. And that is also what we are going to hear in that session. Rainfall recycling is a phenomenon in which forests, and that's my attempt to define the phenomenon, in which forests and trees influence the transport of water over distant locations. Leading experts in this field will present to you now in the coming 90 minutes new insights from science about this phenomenon of rainfall recycling, and also about its implications for climate change, for land management and land policies in implementing the SDGs in generally, and especially also these SDGs dealing with water, land management and so on. And you will also have a chance to learn about another exciting activity. Experts will also present to you some emerging highlights from a global scientific assessment looking at the interactions between forest and water. It's a global forest expert panel coordinated by IUFRO in close collaboration with our partners in the collaborative partnership on forests. So what can you expect from this session? There will be 3 parts. First, there will be a panel consisting of experts in the field discussing the science of rainfall recycling. That panel will then be followed by another panel addressing what all that means for management and policy. What are the implications of these new scientific insights? And after this panel discussion, actually there will be an open forum. This will be your turn, and we are going to discuss who can do what. And then the session will be wrapped up by the director of the Forestries and Agroforestry Program, Dr. Vincent Gitz. However, before we do that, there's a small exercise where I would ask for your collaboration. In fact, we have prepared a set of 4 relatively simple questions, which we intend to ask both now, before the discussion, before the presentations, and then we are going to again ask the same questions after the discussions and the presentations. And you should have on your table these very simple voting cards. So there is a yellow card. The yellow card, because you might wonder what do the colors stand for. So in a very complicated decision-making process, we decided yellow should stand for yes. So if you agree with the statement that we are going to present to you, please raise your hand and show the yellow card. If you are not sure, if you don't know, if you are undecided, white is a neutral color, so that would be the don't know card. So if you are not sure, you raise that card. And if you disagree with the statement, like a referee, if somebody does a foul, then if you disagree, not a good thing, then raise the red card. So that would be the simple instructions. Yes, undecided, no, disagree. And here come the questions. And could I ask to show also the slide with the questions, if we have it? So that is question number 1. Vegetation plays a critical role in the frequency and intensity of rainfall. So, yes, please raise your cards. Oh, I realize this is a very homogeneous group. There are only a few occasional, only the director of STA disagrees with the statement. So, yes, I think we cannot have an accurate count, but I think we get a strong sense of the feeling in the room. So now we increase the level of complexity. The second question. Rainfall recycling should, no, sorry, that is the second question, that's the one. Effects of change in forest cover on rainfall recycling depend on scale and geographic location with fine-tuning of assessment methods in progress. So the latter part is the more scientific part. But basically the question is, do you agree that effects of change in forests which influence rainfall recycling depend on, the scale at which we look, and especially also on the geographic location? Do you agree with that statement? Again, an overwhelming majority of agreement, but also a few undecided voices. Now, question or statement number 3. Rainfall recycling should explicitly be considered in existing climate and water management, as well as in related policy frameworks and rights definitions. So that is the more policy-oriented part. Can I again ask for a show of cards? Well, it seems to me that the number of the white cards is increasing. I see no disagreement, nevertheless. Thanks a lot. And last but not least, the fourth question. New ways to align supply and demand for water are essential to achieve the SDG number 6, which deals with clean water and sanitation, the Sustainable Development Goal number 13, which is about climate action, and the Sustainable Development Goal 15, life on land, at local, national, and global scales, with forests and trees influencing both demand and supply. That's a relatively long one. And again, we have very many yellow cards and 2 red cards. So let's remember that, because we will ask the same questions again at the very end of this discussion forum. And hopefully, at that point, we won't have a show of red cards only, because then probably we would have failed in providing the scientific evidence to you in a convincing manner. So with that, I thank you all for this collaboration at the beginning, and it's now my pleasure to hand over to the moderator of the first panel presenting to us the scientific insights, Dr. Mene van Noordwijk. Mene, you are the co-chair of the Global Forest Expert Panel on Forests and Water, the panel I've mentioned before, but you are also the lead author of Ecological Rainfall Infrastructure, Investment in Trees for Sustained Development, and importantly, you are also the former chief scientist of ICRAF, the World Agroforestry Center. The microphone is yours, Mene.
Thank you, Alexander. Yeah, I think from the voting, it seems, I'm not sure we have the right audience. If we would take the average person on the street in Bonn, we might have a slightly different opinion. But as Alexander explained, the first block will try to give you a quick insight in the scientific part of the story. And I have the pleasure to get 3 people onto the stage here who will be our speakers. David Ellison, who has been the lead author of a major review paper that was published early this year. David, please come on board. Aster Gebrekirstos, who is working and will show us something on the very detailed stuff of growth rings in trees and isotopes within that, and the detective work that helps us understand what goes on. Please come on the stage as well. And then as the third, we have Aida Bergastubella, fresh PhD, recent. Today we heard that you got a postdoc position approved, so very well. For doing work in Burkina Faso on what trees mean for infiltration and others. So we hope to give you a quick glance of the science behind it. So David will first give you, in 5 minutes, a major overview of where we stand with what do we mean by rainfall recycling and what type of evidence do we have. And then Aster and Aida will give you glimpses of the ongoing, more scientific exploration of the details that we are not quite sure of yet. But David will first tell you that everything is clear.
Well, greetings. Oh, you can hear me now. Okay. what I'm going to talk about is sort of based on a number of things, some work I'm doing together with colleagues on modeling, the IUFRO GFEP report on forests and water and some of that discussion, and also on, in particular, on this publication in Global Environmental Change on trees, forests, and water. And what I'd like to start with, if I can, the green arrow goes forward, yes? Oh, there we go, okay. So, I have to speak up. See if I stand over here, then I can see things. Okay, so I'd like to start out with an example to get you thinking about the problem. And this example is based on the Nile River Basin. And if you look at the Nile River Basin, you realize that there are a very large number of people who live on agriculture and so on from the waters that flow through the Nile River Basin, some 200 million people. But a very large share of the water that flows through the Nile River Basin actually comes from the Blue Nile Basin, this area up here, a very small area. So it seems an interesting question to ask, what is the source of the Blue Nile waters? Well, if you're a standard catchment basin hydrologist, what you would tend to look at is total rainfall in the area, and you would notice in the Blue Nile Basin rainfall is very, very heavy. But the question I'd like to ask you is, should we be going further than this in order to be able to understand the hydrologic cycle? And if you go further, what you notice is that a very large share of the evapotranspiration that comes from the West African rainforest, this area, falls as rainfall in the Ethiopian highlands, in the Blue Nile Basin area. Some 30 to 40%, roughly. It's very hard to measure these things accurately, but some 30 to 40% of the rainfall that falls in the Blue Nile Basin area originates as evapotranspiration from the West African rainforest. And of course, also, you'll notice that these reddish areas, there's a fair amount of deforestation going on in the West African rainforest. And so the question there then becomes, what is the potential impact of that on rainfall in the Blue Nile Basin area? And some people have estimated that if deforestation continues on its current track, we could lose as much as 25% of the rainfall that falls in the Ethiopian highlands. And so presumably, this larger scale cycle matters, right? And what I really want you to do is to think about how catchment basin centric are we when we measure the water balance? Should we be looking at other things? Usually you'll find then when you look at the water balance, you look at the precipitation that comes in, you don't ask where it comes from, you look at the ET that goes out, and how much water is left downstream, but you don't usually go further than that. Now, to add one more question to think about, the water footprint people have now published a number which estimates the total amount of water that is consumed by global forests, a very large number. They call it consumption, and I want to ask you, should we call it consumption or should we call it production, right, of water resources? So I like to talk about the concept of the hydrologic cycle, and you'll find that most concepts of the hydrologic cycle are very circular in character. They don't go on in space at all. Even if you look inland, you see a very similar relationship, but the real question is, how is water transported across continental or terrestrial surfaces? Now, come back to the catchment basin. The first thing we never look at is what happens to that ET. Where does it go, right? That evapotranspiration from forests, crops, and other sources. And our ideas have changed about that over time. We see that most of it goes out of the basin, but some of it is recycled within the basin as precipitation. The next big question is, what explains precipitation within the basin in the first place? And if we ask that question and try to look at it carefully, we see that we have a much more complicated world. A very large share of that precipitation is explained by oceanic evaporation, but also a fairly large share is explained by evapotranspiration from terrestrial surfaces. And as soon as you realize that, you realize also that, 2 minutes, okay. So a very large share, a lot depends on the types of land use practices that contribute to that evapotranspiration. And of course, downwind, you have the same relationship for the whole cycle. Our big questions have to do with what are the actual recycling rates within the basin and outside the basin. And we see in this map that the rare areas in red are the areas that are most dependent on continental evapotranspiration as a source of precipitation. So the further inland you go, the further downwind from upwind coasts, the more that cycle matters to you. Forests provide more evapotranspiration for atmospheric moisture than almost any other land surface. They're similar to water bodies and wetlands, but beyond that, croplands are about half. And of course, urban surfaces are close to zero. Land further away from upwind coasts is more dependent and vulnerable than other lands, and land atmosphere actions and land use practices matter for the distribution of water across terrestrial and continental surfaces. Now, to look at this question of whether or not more forests equal more water, I've tried very hard to answer this question carefully, and there are a lot of other people doing the same thing. This one we said that continental evapotranspiration from upwind sources matters most. This paper I said spatial organization is very important, but still, we get papers like this that are based on catchment basin analyses and don't really go farther than the catchment. So this is actually a meta-analysis that doesn't even consider a single supply-side study within its framework. So of course they don't consider any of the studies look outside of the basin, either upwind or downwind. And there are not very many criticisms of the supply-side approach that actually look at its merits. And of course, the FLOSA findings, we want me to be done. 1 minute. Okay, so just to demonstrate quickly, if you afforest a catchment, a lot of water goes out as evapotranspiration, and of course we don't gain much in terms of precipitation, and we lose a lot of the runoff, right? So even from the supply side model, this is what we would find. However, if we afforest the upwind area, we have a big impact on precipitation, right? Spatial organization matters. Some additional runoff, some additional ET going out. And if we afforest both, we have very large impacts on precipitation, ET going out. We lose some of the runoff because of the afforestation of the catchment basin, but you get the idea here. Spatial organization matters. And of course, we can optimize these things based on the calculations that we have, The same thing, deforestation is the opposite effect, right? It's true that if you deforest the catchment, you have more runoff, but you also have slightly less precipitation and a lot less of ET going out, right? If you deforest the upwind area, you lose in precipitation in the basin, you lose on ET going out, and you may also lose on runoff. You do both, and you have less and less water available. You may have a little more runoff, but you have less precipitation. Imagine you have agriculture in this basin. What are you going to do? You have declining precipitation available. And you have potential hybrid examples. So I would like to conclude. I'll go to the next slide and just conclude quickly. So this is the problem with doing this, okay? Forests play an important role in the global hydrologic cycle. Increasing forest cover can lead to increasing precipitation and runoff. The global impact of increasing forest cover does not rule out local demand-side impacts. So spatial organization matters. Forests use water, so trade-offs are possible, but so are win-wins depending on how you organize where you plant forests. Forest-based ecosystems provide an ecosystem service that extends well beyond their ability to produce biomass, carbon sequestration, and this role should be nurtured. I've talked about evapotranspiration. I haven't talked about cooling of terrestrial surfaces, precipitation triggers, infiltration of groundwater recharge, which Aida will talk about. Catchment basins are interconnected, and this is key to understanding how water is transported across terrestrial surfaces. The supply of water available on continental terrestrial surfaces varies depending on the impact of land use practices and the role of connectivity across hydrologic landscapes. And the transboundary and perhaps the transregional concept of hydrologic space should be placed at the core of water and land use planning strategies. It's time for a paradigm change. Thank you.
Thanks, David, and apologies that we tried to squeeze 3 hours of lectures into 8.5 minutes. So we heard a lot at the overall level from the climate side, but maybe you'll ask, where is the evidence for it? Do we really know if we ask a tree? What does a tree know about where its water comes from? So Aster, can you help us talk to the trees and ask them where their water has come from.
Good afternoon. It's a pleasure to be here. And David showed trees, they play a role in the water cycle. But how do we know that trees really transpire and they play a role in the hydrological cycle? So I will show some tools and equipment that we use to measure this, to quantify it. I will show about stable isotopes and trees themselves. Trees and forests are wonderful green infrastructure that appreciates with time, not only in terms of carbon and hydrology, but also in the kind of information they contain with them. So he showed a lot of water cycle, evaporation, transpiration, and ground water and all that. How do we know? We measure the isotopes, carbon, oxygen, and hydrogen. We are what we eat. The trees are also what they fix in terms of water and carbon. I can tell if I measure a hair strand from you if you are a vegetarian or if you are meat eater. If you eat that meat or vegetable in Africa, Asia, or in Europe, it's the same like with trees. So I'm not going to go to the theoretical background, but it is really powerful tool. So, and it's mirrored. This is reflected in the tree rings. There are evidences already that the Amazon initiates its own water using hydrogen isotope. Because there is a preferential transpiration of the lighter isotopes and a preference of condensation of the heavier isotopes. But this is not easy because this transpiration or this cycle depends on topography, temperature, rain amount, and so many things. It's complex. But we know that trees really transpire, and it's different if you measure it on mountain area or on plain area. So it is more on mountain forests. This is our study from China. This slide, we know that the late monsoon precipitation is influenced by precipitation water. We also took samples. You show about Ethiopia, the Blue Nile. It's not about if the trees are really contributing to water cycle. It's the scale. So how do we know? We know that they transpire, but where is the scale? Where is the boundary? Who is going to pay for it? Where is it going from? Where is the wind direction? Where is the largest? We have to look at the large-scale atmospheric circulation patterns, and the isotopes and tree rings, they can tell us the large-scale atmospheric circulation pattern in hundreds of years. So this is from Ethiopia, and you see it shows a large-scale atmosphere circulation, teleconnections, and with possibility of evapotranspiration, atmospheric moisture circulation. So looking at this, the Great Green Wall really makes sense. So if we plant trees in Ethiopia, it will have positive influence in Burkina Faso. Actually, I took samples in Burkina Faso and in Ethiopia, and I can see this belt. So it can help us in negotiations, maybe, which countries do we bring together if we look at these circulation patterns? The same is true in Amazon. And you see, they took sample from Bolivia, and it shows high correlation of about 5 million hectares. So when we talk about water, it's about scale. And more than half of the precipitation is coming from transpired water. The other thing is, okay, trees are really contributing to the water cycle, but also climate change is also influencing these trees and forests. We know that CO2 is increasing. There are frequent drought events happening. So how is this influencing the water use of the trees and forests? Plants, they don't transpire water because it's not because they like it also. It's because they open the stomata to fix carbon. It's a trade-off. Actually, it's linked. But increasing CO2, we see a trend of increasing in water use efficiency. And this is from China. We found it in Africa, also in Latin America. And if increasing water efficiency means plants are opening, they are not opening the stomata as wide as they used to be. So that means, is it less water in the atmosphere? How is this going to affect the moisture cycle? This is also another emerging question that's happening. So we need a lot of studies. These are some really promising results, but we know a lot of complex issues that we don't know, especially in tropics and in Africa. So trees are powerful, and the stable isotopes are powerful, and there are tools and things that we can do to continue this work. Thank you.
Thank you. Yeah, so the take-home message is that it does depend on where you are on the Earth. It does depend on what type of tree we talk about. But the trees themselves, we can use them to tell a lot of the story. The trees are history books. When we are able to analyze their history of growth and isotopes, we can tell something about where their water has come from, the basic question that David asked. Ida, you'll take us to some more complex trade-offs, I think.
Yeah. Thank you, Meine. Okay, so I'm going to talk a little bit about tree cover and the relationship between trees and water yields. Let's see if we get the presentation here. Yeah. So how can more trees improve groundwater recharge in the seasonally dry tropics? So this is a diagram that illustrates the dominant paradigm in forest hydrology right now. And it is that when we increase tree cover here, we have less groundwater recharge, dry season flow, or total annual stream flow, less water yields. While if we decrease tree cover, we always have improved water yields. This is the dominant paradigm in hydrology right now. And this is always explained because trees transpire and intercept more water compared to shorter vegetation types such as grass or agricultural crops, for example. And on the basis of this trade-off theory that we call it, there have been multiple concerns that establishing trees in drylands may put into risk already scarce water resources. And this in turn has led to criticisms regarding carbon sequestration programs or restoration activities that involve planting trees in drylands. But the fact is that the scientific evidence for this trade-off theory has some important limitations. The first is that most of the studies are biased towards humid temperate areas. There are almost or very few studies in the tropics and almost no studies in the semi-arid tropics or arid tropics. The second important limitation is that the studies focus on the impacts of a few tree species, and this is eucalypts and pines mainly. The third limitation is that they do not consider soil degradation, which is widespread in tropical areas. And finally, the fourth main limitation is that they compare extremes. They compare close forest versus open land, but they neglect any considerations to intermediate levels of tree cover, which are also widespread in these areas. So in view of these limitations, we developed and tested a an alternative theory, and which is that at tree covers, at the intermediate tree covers, at some point here, we can maximize groundwater recharge. At tree covers below this optimum, we have what happens is that more trees give more groundwater, and this is because the positive effects that trees have on improving infiltration and reducing soil evaporation exceed the extra transpiration losses we have here from trees. And above this optimum, the opposite takes place. And this, of course, has profound implications for the environment and for livelihoods, and connects very well SDGs 6 and 15 and 13 that we were talking here today. So far, we have evidence for this for a site in Burkina Faso, but we believe that this is going to be widespread over many areas in the seasonally dry tropics. Right, and now I'm going to try to put this into a wider perspective and connect it to rainfall recycling. So there are a number of unknowns that can shift where this optimum tree cover is. And some of these unknowns are going to play an important role if we consider larger scale areas. And here I have, here I have highlighted transpiration and evaporation flows. So what these flows are supplying water vapor into the atmosphere, and some of this is going to be recycled locally. This is this local moisture recycling, while some is going to be exported from our system and contribute to rainfall downwind somewhere else. Then we can also think about what is happening to groundwater recharge and surface runoff that is generated in the system. Maybe, we don't know, this is going to support vegetation somewhere else, and this vegetation in turn is going to provide more evaporation into the atmosphere that can perhaps come back into our system in form of rainfall. We can also have imports from somewhere else. So at the end, we might have influences on rainfall. We can also have ice nucleating particles that are emitted by vegetation into the atmosphere and that can trigger rainfall. But what the net effect is going to be is hard to predict because it depends on factors that change in time and space. So I hope it's unknown, but maybe it's a ground for a good discussion here. Mm-hmm. Thank you.
Okay, thank you. Thank you, Ida. Unfortunately, we've been running a bit over time, so the idea would be to have a quick question if people have burning questions that stop them from understanding the next part. But maybe if you just have a buzz group with your neighbors for 2 or 3 minutes and check if there's anything in here. Early on, we all said we agree with everything that's being said. Do you have any reason to disagree by now? Are there questions that you have about the technical side of the work? I think the overarching thing is that the things started changing when David changed the question. When we don't ask where does the water come from, but we ask where does the rainfall come from, then a lot of the considerations that we have about water and water balances become of rather differently. Now we've seen then beyond that leads to further questions about it matters where you are on the world, and that the specific detail of what specific trees tell us about specific places can be unraveled by methods that we now have. And in the last talk, we see that when you start looking from the groundwater side, you get some further trade-offs in the game. So maybe just buzz with your neighbors a few minutes and then we'll move on to the second block. Yeah? Sorry, it was a bit rushing time. Yeah. But start? No, I think it's working. It's working.
Okay. Let's keep 30 seconds to the people when I start, okay? Okay. Okay, so I'm so sorry for interrupting your discussion. It seems that the discussion is really interesting, but we will have time after this second panel, and we can further discuss. I think that this is a really, really interesting topic, and I think that for me it really opened my mind a lot. I'm really, and I think that we will have a very nice discussion after the second panel. So now let's move a little bit more. We have very interesting insights, new scientific insights about this rain recycling. And let's move a little bit to discuss about the implications that this new science knowledge or these new insights may have for climate, land, and water policies. And that's the topic that we are going to discuss in the second panel. And I'm very glad to present three of our panelists. Meine van Nubik is our first panelist. He has been already introduced, so he's working as commented before, at the World Agroforestry Center. And Meine will help us to think about the challenges of this relatively uncharted territory and from a policy perspective. Please, Meine, if you can come to the stage. So our second panelist, Daniel Murdillarzo, he's a senior scientist. Did I pronounce it properly, Daniel? Sorry. He's a senior scientist at the CIFOR, at the Center for International Forestry Research. And Daniel will help us to explore the potential solutions considered within the existing frameworks, like the SDGs and also the REDD+ and NDCs. And our third panelist is Hofer Holger. He's also a senior researcher from the Potsdam Institute for Climate Impact Research here in Germany. And also Holger will help us to discuss about the big challenges, considering that the effects of this rain recycling affects across borders and scales. So please, let's start with Meine.
Yeah, thank you. Yeah, so I'll try to summarize what we've had so far, but in terms of the policy arena, this is the starting point. So we have a concern about climate. Oops, I do the wrong thing. I hope the pointer would be here. Sorry, there's no pointer. Okay, thank you. Oh, yeah, okay. Yeah, so we have, within the world, there's a lot of debate about climate change, and the convention about climate change is, other than what people think, not a convention about climate, but is a convention about greenhouse gases as one of the major things that change climates. And of course, greenhouse gases come from the use of fossil fuel, but they also are part of what forests and trees outside forests interact with. So we have a quite elaborate framework on how climates change through changing greenhouse gases, and that leads to changes in ocean temperatures, and that leads to changes in how much moisture is around, And we may have, as an effect of changing climate, the current level, we may have changes in rainfall. On the other hand, we have a lot of work about water, and we have more people in the world and they need more water, and we have a sustainable development goal about creating more access to clean water to people and sanitation, and there are lots of problems on that side. And yes, if the rainfall is changing, there might have some impact on what happens in the water world. But beyond that, the water world and the climate world interact through rainfall, but rainfall is a given, and that depends on what happens in the global climate. That's basically where we are right now in the policy arena. I think from what we've heard so far, there is a gap here. There is potentially an important story that forestry and trees outside forest influence rainfall. And they influence rainfall at 3 levels. When they use water, they recycle water, so they bring moisture back into the atmospheric moisture pool. They also influence what we call the triggering of rainfall, so between having moisture in the air and rainfall being there, and David didn't have time to discuss in detail, but in the review paper there's lots of very exciting science on that. So there is an effect on the moisture itself, there is an effect on moisture becoming rainfall, and what Ida told you some about forest influence, what happens with rainfall, and whether it leads to floods and disasters or whether it leads to usable water. Yeah? At the same time, we've heard that forests are using water, so they are in this frame. So when we look now, we see that the whole frame between climate, forest, water, and people looks quite differently with this new knowledge inserted. And it is not, as we said, in the current policy frameworks, but it has important consequences that this missing middle, the relation between vegetation, forest, and rainfall is not only through the long route of the climate change and the ocean temperature, whatever, but there is a good evidence now for a much more direct link. Now, as Alexander said in the opening thing, actually, whenever we work in landscapes, that's what people tell us. But until recently, most scientists, and I've been included in that, would say, sorry, we don't understand, we don't measure that, we're not quite sure what to do with it. So now our message to the policy part is, hey, we have enough evidence that it exists, we're working on the details, but let's think about how the picture looks when we think of the policy arena in this frame. Yeah? And within that, yeah, so the 3 key points here are that the Climate Convention is about greenhouse gases. That's its mandate, that's its role, that's the focus. There are a lot of direct climate effects of trees and forests that matter to people. They're outside that. And same time, that landscapes are a good place to bring to coherence. Now, the further point is that we have this daily connection. So if we look at there are exciting maps about the world where we see how is the wind and where is the moisture. Now, exciting thing here is you see the patterns of wind all over the oceans or whatever, complex patterns. But you see here areas over the Amazon, over Congo Basin, over here, where there's a lot of moisture in the air and the wind speeds are very low. And that means that moisture stays in the atmosphere, recycles as rain. And over the Amazon, rainfall can, a same drop of water coming from the ocean can fall 3, 4, 5 times within the Amazon basin because the recycling speed, the recycling is so low. At the same time, if you are somewhere in the US or some places with high wind speeds, it dissipates much more quickly. So it matters where we are on the globe, but rainfall recycling leads to these daily connections. Yeah, we've seen before, yeah? This map David showed in some version. If we look at the parts in East Africa, we'll see that almost every drop of evaporation in East Africa comes back as rainfall elsewhere in Africa. So making rules that eucalyptus trees use too much water and we shouldn't have them. No, whatever water they use comes back somewhere else as rainfall. Those rules may be relevant in South Africa, they would not be relevant in East Africa. So we get that type of nuance into our statement, yeah? And so the 3 core areas for this is in Latin America, on the African continent, and what goes on in the Southeast Asia part. So the specific parts of the world where this rainfall recycling has emerged as a major story. So in summary, I think we have good reason to say that the Sustainable Development Goals about water cannot be met unless we actually know where the water comes from, and that now means where does the rainfall come from. that the climate stories about SDG are not just about carbon, but it is this much more direct effect of vegetation may well be at least as important as all the things we have been talking about in terms of emissions and reducing emissions. And that there's an important scale at the local level where everyone knows about trees and water towards the global, that we can tell the story in much more coherent ways if we follow these new paradigms. At the same time, it does not yet exist in global agreements, and it does not yet exist in existing policy frames. And hopefully today we can give a little further push that it would be there in future. Thank you.
Thanks a lot, Meine. It's really a very impressive picture, and thank you for giving us the big picture, and also how can we connect global versus local, and also thinking about this piece of science as a connector between the local and global scales. So let's move with Danielle to explore the potential solutions within the existing policy frameworks.
Right. Thank you very much. It's a pleasure to be here. And I guess the question that come up to us, especially to me, is what does it imply, or what do they imply in terms of daily life? So I'm inclined to look at from relatively smaller level. And if we can think about how forests can do for water and at the same time for climate. How to move this forward? Big clue. Okay. So I pick up what David left with the logo. It looks like a SDG logo. We did start exercise before coming up to that complicated papers. We were thinking of putting a pictorial kind of logo to speak itself. What does it imply? Certainly, forests can promote rain because it generates water vapor and also change the pressure so that air can move. So the movement of air, which bring water vapor, really drives what's going to happen in that particular spot, be it landscape, watershed, or even local at farm level. So that's very big picture of how the movement took place. And we are thinking also at the local level how forests can help infiltrating and also recharging water to the ground, as Aida mentioned earlier. And it depends. It all depends where it is and what kind of trees we are planting there, or how many trees it is going to be removed or planted. And certainly people are really care about flooding and certainly drought. So the presence of forests really can help. And it's just a matter of juggling how much do we need to have on the ground. And one thing which perhaps somehow connect between water and climate is one single logo here to talk about the local climate. Certainly forests and trees can absorb the so-called latent heat, so that places, cities with trees has cooler air because most of the energy is absorbed to evaporate water. So the surrounding, the sensible heat will be less so that we can feel cooler in that kind of situation. So that's what forests can do with water and a little bit of to climate. So I'm not going to talk about this because this is too big for me. This is the watershed in the air, if you wish, but I'm going to talk on the ground. And going backward to 2009 work with colleagues in SLU, with Anders Malmer and colleagues there. And Anders as a student, the student has another student, which is Aida, who are here. And I have the privilege to work with all of them. The father, the son, and the granddaughter here. So it's a privilege. I hope I'm not going to be a deadwood here. So it depends what kind of trees we are planting to generate infiltration and also to help runoff and fill the river. Basically, these two pictures tells us that it's not easy. It's not going to be short to understand what's the behavior of the landscape in doing that. We only managed to do it less than 10 years. It can go crazy afterward, and if the management changes, they will change also. So when we talk about this distance and also the canopy density, where we realize that there matters in terms of recharging groundwater. So with regard to carbon, certainly forests play a very important role. This is the understanding that because of that, forests can play both as source as well as sink of carbon. And the very recent data indicates that forests getting less and less being a source of carbon, meaning that deforestation is managed or controlled, and plantation also increasing. So what's going to happen with the water? So we really need to find a new way of governing forests. So this has a policy implication in terms of forest for water or forest for climate. In the watershed level, certainly there are a lot of issues which are local or even perhaps national at the most. But many of the carbon or climate agenda are global. So these two things, to some extent, like contradicting, but can also be supplementing each other if the planning people are really thinking about both sides. So win-win can be the solution, but in many cases it can be a trade-off. Trade-off between forests or pick one of them, because both of you cannot pick both. So in terms of SDG, I think this is a globally relevant thing, but implementation is really on the ground and in many cases at national level when they are asked to talk about the equitable use of water or access. In many cases, it's also transboundary issues, but helping countries to have resilience to climate change, climate adaptation is very crucial. And resource is very important here. Resource for climate, unfortunately, but not resource for water yet. And lastly, when we are talking about SDG 15, I think sustainable forest management plus this and that, like red issues related to conservation of the existing one is very crucial. And in many cases, they also cut across the boundary, like mountain wetlands across the globe, in dryland, in Africa, etc. So it will depend how country will handle this, but certainly they have to be linked up with the global level. Thank you very much.
Thanks a lot, Daniel, for giving out this perspective of potential win-win solutions and also going back to the trade-offs. So let's have our last discussant. Holger, please. Do you have a microphone?
Does it work? Yeah.
Yes.
Thank you very much. I did not prepare any PowerPoint slides. 5 minutes, 5 quick conclusions from my side, so to speak, preliminary maybe. The first is more of a question, what's new? All that has been said here has been known for 20 years, except for that the methods have been refined a little bit and that we have slightly better ability now to trace these effects. What's really new is more the need to bridge from that scientific knowledge that emerged in the 80s and 90s to application, which hasn't happened yet. We have some new knowledge about tipping points, critical tipping points, which are affected by these teleconnections. That's new. We're also moving from teleconnections to telecoupling. That's new, managing these teleconnections, or at least trying to manage them for resilience. That's also relatively new, the knowledge we have there. My second point is we should start from existing frameworks and concepts, feeding in and adding value to them with this new, not so new knowledge. We can broaden these frameworks by adding information about rainfall recycling. For example, multifunctional landscapes. There is a new function that we haven't really taken into account yet. Ecosystem services, there is a new function, external ecosystem services that manifest themselves elsewhere. That's new. We can add new flavor to the term of environmental justice or to fair shares of the global commons, and not the least also to take into account planetary boundaries. As you probably know, the the land boundary is really shaped according to this mechanism of rainfall recycling plus some others. And we can make use of the term nexus to look at the interactions between different scales, regions, and also sectors. Rainfall recycling is not the only ecosystem service that we will deal with when we manage landscapes. Third, messages need to be tailored to the target audiences that we want to address, in our case, policymakers. And there are certainly a number of policy frameworks that lend themselves to take up some of this knowledge and for adding value to it and for providing a new spin to it. I just mentioned a couple of them here. One that's very hot on the agenda is bioeconomy, which largely depends on globalization and also on land use changes. The Common Agricultural Policy, which is externalizing effects directly via trade, but also via land use. And then we can also think of the circular economy approach, which may actually lend some of the principles from the recycling of water. Fourth, how to trigger action by accounting for rainfall recycling. I would say let's identify win-wins, or no regrets if you like. And we heard some of them. Asta was talking about the Great Green Wall. We can look at it from a rainfall recycling perspective. Aida was not talking about, but I'm assuming that she was meaning also agroforestry, which is a type of land use that can get that can add value from a rainfall recycling perspective. And obviously avoiding deforestation, which has been on the agenda for many reasons, can be supported with the reasoning we heard today. Well, so what we have lastly is increase in complexity, so to speak, when we take into account these additional effects. We want to account for global effects, of which there are many, and that teleconnection via atmospheric moisture transport is one more. We need to take it into account when thinking global and acting local. We need to bring together top-down and bottom-up perspectives, and what we heard here is a top-down perspective. So I would end by saying welcome to the Anthropocene.
Thank you very much, Holger. I think it was a brilliant summary of what we said, and also point out many questions and how can we go forwards to connect this scientific knowledge with effective policies or effective actions. So, because we don't have much time, we have just half an hour, I propose you to go ahead with a discussion. And this discussion will be led by Vincent Gist, who is the director of the Center International for Forestry Research. And so I give you the stage, Vincent, yes, the stage is yours. And I think that all the panelists stay here, or maybe the other three panelists can come here. Okay, so.
Thank you. Thank you, Paola, and good afternoon to all. I guess the discussion will be. Please. Well, we'll make space. Given the number of yellow cards, I guess the discussion will be at the beginning. The yellow cards, the yes card at the beginning. We expect the discussion to be as much within the room than amongst the panelists. One, of course, what we've not learned, because in fact it was good to remember that this is not new science per se, but it's science that is being refined and that is now trying to fit into a policy space or implementation space that sometimes are filled by other issues like carbon or land or soils. Precipitation availability and variability is one of the major channels of climate change impacts on agriculture. So I guess that would be a reason enough in itself to consider the important effects of trees and vegetation on the water cycle. both the recycling of atmospheric moisture, but also the triggering of rainfall and the effects from local to national and continental scale. So now the question we can ask is who can do what with this knowledge and these facts, how to optimize the contribution of forests and trees to the regulation of the water cycle, most technically, technical issues, but also whether the effects can be taken into account by policies, institutions, or incitation schemes. We know that for climate change, there are several frameworks that have been put in place quite recently, the NDCs, there was always the NAPs, the National Adaptation Plans. Can we help countries prepare measures that take these effects into account at different levels, the density of tree species in the landscape or the spatial organization of trees, or including farming systems such as agroforestry in these measures. Second, what does this tell us for international support programs to the NAPs, to the NDCs, including the funding dimension of these international programs? And then, of course, forests have been known by science that is perhaps even older than this one, that they can slow down climate change because of the carbon cycle. Now they can have also other effects via the water cycle. Can policies such as RED Plus or schemes such as RED Plus take this into account? Can this provide further arguments for funding, for incentives, for resources? And then there are other sets of policies regarding to water, and especially transboundary policies or policies among transboundary basins that deals with the repartition of water and also the rights. And when we change the question from when does the water come from to where does the rain come from, how does that impact the ways these transboundary basins needs to work internally, but also between themselves? So I can also cite the question of restoration policies, the big theme here in GLF. How can that create new incentives or new solidarities between places where restoration should take place and places which need rain and rainfall stability? So I would like to ask the room whether first, if there are some remarks or questions to the panelists, or questions that you ask yourself, and then also the panelists can also discuss amongst each other about some different aspects of this question. So first, do you have questions? Because the cards were all yellow in the beginning.
My name is Frank van Schouwbroek from Farm Tree Services. I have a question, and that is, what I understand is that to make the case for conserving forests or trees in the landscape for some sort of a watershed to influence rainfall, hopefully for the better then. But I'm wondering if that's the right question, because I think, for example, in your presentation, sorry, I don't remember your name, but your presentation about how water goes into the soil is not the right question, that trees in a landscape keep the water longer where it is and can therefore have a more richer, biodiverse, productive landscape. Is the question clear? So is it the right question to? I can see the rain in the Amazon forest, going over a couple of cycles, but in the semi-dry areas, is it not better that when there is all of a sudden 150 millimeters rain in a month, that the water actually stays there when there are trees, so that it becomes longer productive and farmers can make some food and money and so forth. So wondering if the question is the right, if this is the right thing to tell to our policymakers when it comes to forests. Sorry, when it comes to trees and landscapes.
Thank you. So perhaps, yes.
I would respond by saying I don't think it's an either-or question, really. I mean, there are multiple ecosystem services. There are multiple ecosystem services that arise from connecting forests with water cycle relationships, and a lot depends on what you need at the local level. You can, of course, try to promote additional atmospheric moisture for precipitation, but groundwater recharge is also a very important impact. Storing water in the soil as a result of having more forest cover is very important. All of these ecosystem services can be utilized and strategically used, but I wouldn't want to argue that it's either one or the other, or we should only be looking at one aspect or the other aspect. I think all of these services are useful.
Just to, how to say, biophysical aspects to be addressed here as well. One is clearly the shift from unproductive evaporation to productive transpiration, which you want to maximize. And the second is this cascading recycling. If you take a continent, you may have several loops. So a comparison needs to be done between just letting it run off and going to the seas, unproductive again, or having several loops where it goes through several productive, biomass-productive stages again.
Well, I think a perverse version of what David was showing is if you want to maximize the amount of water in your rivers, you tell all your neighbors that forests are so good and you cut them down yourself. Yeah? So you benefit from any rainfall recycling from adjacent watersheds, and you reduce the amount of water that's used within your own watershed. So we keep telling people how important forests are, but at the local scale, I think that's a perverse version of what David was showing, but it does show that these questions of scales, that the rainfall recycling operates at the scale higher beyond what we've been looking at in much of the previous work on where we see the additional water used by forest as potentially as a problem. Yeah.
In the climate change world, there is a term called tier in emission factor. I wonder if we can create similar kind of situation for water use in that kind of situation, meaning that if you have higher tier, it is more site specific. You cannot pick up a number which are generalized for everywhere, any places. That will be misleading. So I would encourage people to have their own factors, be it emission or transpiration, evaporation, percolation rates that are higher tier.
Okay.
Yeah.
Okay, my name is Philippe Maillot. I work for the European Commission, the Biodiversity and Ecosystem Services. And I have 2 points. Maybe one SDG was missing is the energy one. I don't remember the figure, but it's really linked to water. And I will come to the second point through the energy, because what we have seen in many programs that we are funding, that now the policymakers, even to the high level, the commissioner, the DG of ODG, which is not really aware on environmental issues, now he realized that really the protection of national parks like Virunga in DRC or Bale Mountains in Ethiopia is really crucial for the water regulation and therefore for energy production. But my point is, if you speak about the increase of precipitation in Ethiopia due to the reduction of deforestation in Congo Basin, that's a message that he will not understand, he will not take home. So we must be extremely careful with the decision makers. And my point is, and also what can you do in terms of policy? Of course, the overall policy is important, the red message is important, but don't forget that we work a lot at national level. And that's where we have the most of the leverage, even the NDC. I'm not sure that the DRC will reduce deforestation in East NDC because it will increase the precipitation in Ethiopia. So we must be always careful on those messages. So it's more a general remark.
Yes, the question being whether a country that can support these schemes, let's say a developed country, whether this could give additional elements to support the restoration schemes given some beneficial effects elsewhere. That's, I think, the way perhaps to see the question.
Hello, my name is Mar Modem, and I'm part of the United Nations University here in Bonn. And it's linking up to the previous question on the policy perception. And you have a very interesting question or change in the angle of the questions from where the water comes from to where rainfall comes from. But what if the SDGs have a deadline and there's at least an agenda from here to 2030? Probably what policymakers want to hear is, can you make it rain here? And can you stop the rain there? So my question is, what are the trade-offs in the SDGs agendas and other pushing relevant global issues to the research agendas? Can we get into bad science, rushed science because of pressing needs, funding, biases, and similar?
Can we make it rain at the right places for the SDGs?
Well, I mean, yeah. A few years ago, we tried to raise that point at that level. Now, in searching through what type of international conventions that we have, somebody pointed me that actually the Convention on Biological Warfare from the 1970s has rules that countries are not supposed to tamper with the rainfall of their enemies. That the basis of that was the US were using cloud seeding in the Vietnam War to induce rain at points where it is. So there is actually some precedence within international. And clearly, this teleconnection stuff, telecoupling is highly sensitive. And when countries realize that they have control over or they have ways to influence climate in neighboring areas and elsewhere in the world, yes, that can be very much misused. But sorry, that's how it is. So the one thing, and that's back to your point where the telecoupling, I think I've been trying to tell people in China that the way they engage in Myanmar and other countries in Southeast Asia, that it could very well have impacts on their own rainfall. That's, I think, a point where at least creating questions, creating awareness of that these things are coupled, and there may be consequences that they don't want them, whatever. So my sense would be, yes, it is potentially explosive stuff. It can be very much misused, but the only way to prevent misuse is to make sure that we all know what it is and that we get the positive potentials on the table as well. Playing ostrich doesn't help.
Thanks. If I understood you right, you were also asking whether we are risking to rush into some conclusions that policymakers should not yet take up. I think the opposite is the case. We have quite a lot of knowledge, increasing steadily, and we should make use of it. And that's not to say that the scientists themselves should come to the conclusions and deliver them. It has to be done jointly with the policymakers. This term of co-generation of knowledge that's really relevant has to come in here. But to my mind, the status is more that the knowledge is sitting in journal publications and not reaching out, rather than that we're risking to rush out too fast. And one example is where I mentioned the tipping points. When we're at the limit of, for example, dryland farming, or when we're in a monsoon system where everything depends on the onset of the monsoon, that's where it matters so much whether a slight change in rainfall happens or doesn't happen. And there is not enough knowledge, never, but there is knowledge that needs to be translated into policy making. And to the messages, I do believe it does matter for a policymaker in Europe whether there is what the effect of a land use change somewhere in sub-Saharan Africa is, because we're doing it all the time. Some of the European countries are externalizing their land use to, half of their land use is taking place elsewhere for their consumption patterns, in Africa, in Asia, and in Latin America. And there are these policies that do it, It's the common agriculture policy, it's the bioeconomy policy, it may be the circular economy policy, it's the trade agreements. All of these affect changes in rainfall recycling. So it's not messages in the distant, it's something that's very relevant for policy making in the EU, in Brussels.
Yeah, I would like to add to what he said. Actually, I think the message here is clear. What we are saying is trees and forests, they play a role nationally in terms of rain and also in terms of groundwater recharge. I can give you one example from Ethiopia, for example. So they do restoration, they do tree planting. When you ask the farmers what is the benefit of this restoration, they tell you the first thing is water. And they explain it, it's a water bank. You put your money upstream and you harvest it downstream. That's how they explain it. It has a role at national level. But there are also regional initiatives like the African tree planting initiatives or Latin American tree initiatives and the Great Green Wall initiatives. So we can bring in this also to this discussion. What is the importance across the region in terms of water, not only carbon? So the other challenge in forestry is about valuation. It's just giving it value, not only about carbon, but all the ecosystem services, yeah, in terms of GDP and all. So this is the issue that we are trying, I think, to bring into this discussion. It's about valuation.
Yeah, I just wanted to add 2 more points. First, one of the questions that comes out of this is really how do you create a decision-making or negotiation framework in which you can actually consider these larger scale cycles. Because, say, let's look at the Nile River Basin example. The countries that negotiate over the use of the Nile River are the catchment-linked countries, and there's no connection to the West African rainforest of any kind, so there's no link to the source. So the question that we would be raising in this context is how can you create a discussion framework which is actually capable of thinking in these larger scales? Because clearly it matters to the rainfall. And if you think about it this way, Egypt and the Sudan, right, sign an agreement between themselves saying they have the rights to X amount of water on an annual basis, thinking that that is somehow a function of upstream parties who don't sign the agreement. But of course, it's also connected clearly to the available evapotranspiration from the West African rainforest. So if you don't include these things in the discussion framework, it's a powder keg waiting to happen, right? And to also talk briefly about this question of throwing money at these kinds of new ideas, a lot of money already has been thrown at trees as a source of carbon sequestration without thinking about water. And I think the consequences of that are far more serious than throwing money at the use of trees as a potential carbon mitigation resource, in addition to thinking about water. So it's incorporating those 2 things that is going to bring you a much larger return on the investment that you make.
Thank you, David. Are there any comments from the room or questions or doubts?
One was quicker. So thank you very much. Very interesting discussion. My name is Katja Heuber. I work with GIZ. So one question, you're looking at forest cover. So I wonder whether you have also qualitative studies regarding biodiversity. What kind of biodiversity do we need to have the optimum effect that you like to actually get out of the systems?
Well, one point that of the specific form of biodiversity that is sort of behind the scenes here is the biodiversity of phyllosphere bacteria. Now, what does this whole thing to do with phyllosphere bacteria? But there's been exciting work that shows that bacteria that live on the leaves of plants have a life cycle that means that they go up in the air and they help creating ice crystals that form rain, and they come back with rainfall, and they create plants on which they can live. So that's a form of biodiversity that is actively engaged in creating rainfall. There's similar stories about spores of fungi that play a role in that front. They may link to conditions of various forests, etc. We know hardly anything about the differences between species of trees and how much they contribute to the specific effects of rainfall. There have been many anecdotal stories, and in much of the local knowledge, people have stories about these type of trees create rainfall and those don't, that with the new techniques of understanding what actually happens with the bacteria and the microbes around them, there might be a whole world to discover in that what type of tree matter. We know that conifers differ from broadleaf trees in many aspects related to water, but probably also in the type of rainfall generating mechanism that they are related with. So I think there's a whole new world of biodiversity things that we actually do need to understand, and does it matter what type of tree it is, what type of vegetation, in how much they play a role towards this triggering of rainfall and the biological agency involved with it. And I think that's a topic that I think the methods are there. We have the experts who tell us what to do, but it hasn't been done in a comparative way at all yet. So I hope we can get some people to open up that book on biodiversity. Holger.
A quick addition, since we're talking about multifunctional landscapes here, and I mentioned the term resilience, which strongly depends on general resilience building as a matter of diversity to a large extent. So if you reduce your diversity, whatever it is, in this case biodiversity, chances are that you also reduce your resilience of the multifunctional landscape. So it does not serve the purpose to look only at one factor to optimize only the rainfall recycling, for example, by way of monoculture forests. So the type of landscapes we're looking at need to take into account different factors, some kind of multi-criteria optimization, of which rainfall recycling is only one, biodiversity is another, and clearly many others come in, whether it's food production or any other of the ecosystem services that were mentioned.
Yeah, I also wanted to comment a little bit about this question and how different tree species affect groundwater recharge. And this will be a factor, of course, of how they improve soil properties and how they intercept water and transpire water. And this is going to change depending on the tree species. But there's very little information about this. As I said, transpiration, there's almost no studies for example, native tree species in African drylands. But I guess that if we want to minimize transpiration, for example, we should go for drought deciduous tree species that shade their leaves during the dry season and consume less water, perhaps. Then we can look at tree root architecture and canopy architecture and try to find those species that promote soil macropores and infiltration into the soil. But there's little work on that so far.
Yeah, I completely agree. There are really, especially on the indigenous species, there is very little knowledge, but the technique is there. When you talk about optimal tree density, it also depends on the rooting depths, where the water is coming from. Because different species, they have different sorts of water and different rooting depths. So we need to look at this. And we talked about resilience. Okay, the deciduous species, maybe they are taking water, soil water, but are they really coping up with the increasing temperature and drought? So there are a lot of factors we need to know when we talk about replanting. So optimal tree density, biodiversity all depends on the ecophysiology of the species as well. So we have the technique, we have this isotope, we just don't need even to dig. We can just measure from the wood and then we can tell which species is using deeper compared to the co-occurring species. So yeah, I agree.
I'm adding. Another qualitative issue which is not discussed today is the load of pollutant in the water bodies, when especially in the issue of international water. I think it's becoming more and more crucial to understand the loading of pollutant, and also the very example of sediment. I'm not sure if, for example, in the Mekong Basin, the Vietnamese do not want to have sediment loaded up in the Mekong River. Maybe they expect that. So it is somehow a problem, but can be a good problem to have if sedimentation will help building the land in the delta and cope with sea level rise and this kind of stuff. And certainly, the source of sediment and other pollutant can be tracked down. Isotope method is one of the way to do that.
Thank you, Daniel, and thank you all. I think perhaps now it's time to just, please, the panel can stay in front. We can perhaps have another look at our 4 questions and then see whether we have achieved our goal of lowering the interrogations and the confusion, or perhaps just new questions have been raised. So can I ask question number 1 on the screen? So, does vegetation play a critical role in the frequency and intensity of rainfall? Well, it's almost a full yes. Second, less confusion. There were a couple of whites in the beginning. Second question, please. The effects of change in forest cover on rainfall recycling depend on scale, geographic locations, and there is also the need to fine-tune the assessment methods. Do we agree on that? Okay, so more science needed, indeed. There is already a good amount being known, but we need to know more at different scales, especially finer scales. Third question. Rainfall recycling should explicitly be considered in existing climate and water management, as well in related policy frameworks and rights definitions. There were some, okay, so it's a yes with some white, and there have been also messages in the panel of the need to do it carefully, if so. The last question. New ways to align supply and demand for water are essential to achieve SDG 6 on water, SDG 13 on climate, and SDG 15 on life on land at local, national, and global scales with, and that's, I think, the important part of the question, forests and trees influencing both demand and supply, or revisiting the production and consumption concepts. It's a yes with some whites, meaning perhaps more clarity. Madeleine, do you want to say why you are giving a white?
Hello everyone, my name is Mehrdad. I'm a student of Hohenheim University. You tell something about the canopy cover, but it's still not clean for me. But you know, which canopy cover? You showed some flowcharts, and what is the optimal one? I didn't understand actually. And is it depends on specific species, and based on which region you talk about that?
Yes, and then thanks for the question. There'll be time perhaps after the panel, because we're running out just 1 minute to get the detailed explanation on the water side.
Yeah, I just think that we should not limit to 3 goals. I think there are more goals to take in consideration and where this discussion has to be introduced, especially goal number 2.
Thank you. So it was perhaps a very challenging audience, because you were perhaps all of you quite aware of the issues which are, in fact, not so new as perhaps we can claim, but when we see that from a policy perspective or from an institutional perspective, it's perhaps a bit newer. We've seen that it's a very technical theme. It's still pushing some scientific boundaries, and at the same time, I think it's the mission of scientists and researchers to give some early warnings and to give those with the provision that there is still more to be known, that there are uncertainty. We shouldn't rush into frameworks that wouldn't be able to accommodate the uncertainty or push towards wrong decisions. But at the same time, we are interrogating some of the science policy interfaces. I think that's also one of the core missions of GLF, and I guess the discussion, including first the scientific aspect, but also including the institutional dimension, or how can institutions deal with this matter? Do we have recommendation? All of this we're really waiting for eagerly for the GFEP report on water and forest to help us understand how the different institutions can embark all of this science and all the ramifications. So I wish to thank the panelists for the very clear presentations and the room for the contributions to this discussion. Thank you.